estimated salary. Okay? Estimated salary and purchased or not. He purchased it or not. This estimated salary is nothing but salary. It is just for identification purpose. We don't want this ID at all. So how you remove that one? DF social dot, first I will see the columns, guys. This is a column, this one I want to remove it. Okay, how I'll do it? DF social dot top user ID access is equals to now this will be dropped down. Okay, we drop the first column which is called as user ID. We don't want that. Now DF social, I will keep it in. Now next step is what, guys? We have done whatever required columns are there. आपको इंटरव्यू का आया कॉल वहां पे, मैं एक नंबर देता हूँ ना, कॉल करो, वो ले जाएंगे. ठीक है. Next, what is the next step, guys? First, you got the data, you removed unnecessary stuff. Now, next, what is that? Encoding, outlier detection. We have to look at. Let's see that if I have any null values. How to see null values? Is dot sum. When you do this, you will get all the null values. Is there any null values? No. So we can go to the next step. What is the next step? Encoding. Okay. What is the next step? Encoding, guys. Okay. So in my social, which one I have to encode it? Gender. How you will encode this one? One hot encoding or PD get dummies, right? Now let's do it with the PD get dummies. PD dot get dummies. Okay, which one you want to remove it? If I give some completely like this, what will happen? I'm giving this complete social. Because there is only one column is categorical, right? Remaining all we can't convert it. Let's see that what will happen. Right? What is a column is converted? Gender. Where is the actual gender? Huh? See here, how many columns are there? 4 columns. Which one I have to encode it? Gender. So usually till now what we were doing is we were taking the gender column and we are encoding it. We are converting it to numerical, right? Which one we are using it? Which mechanism we are using it? Get dummies or one hot encoding. Why you are not using the ordinal encoding? Ordinal data. It is not an ordinal data. So now what I'm doing is just giving the entire set into get dummies. Directly I'm putting the entire data set into get dummies. Once I put it on the entire data set to get dummies, what you're going to get it? See, whatever is males are there, that is converted into gender underscore females and gender is equals to males, like that. You got it. Now original gender column is been automatically removed. It's been removed. Automatically it removed the original gender column. Now, if you want, you can just keep same. See, here social 1. Now you see DF social 1. Got it? Yes. Okay, guys, how to rearrange the columns? Is there any way we can rearrange the columns? What is the way? Huh? Columns. Columns आ गया. तो कॉलम लेबल्स चेंज होगा, नहीं कॉलम लेबल चेंज होगा, कॉलम चेंज नहीं होगा। आई वॉन्ट द कॉलम पोजिशन शुड बी चेंज, ये कॉलम नेम चेंज कर रहे हो। So in order to change the column positions, guys, social1 is equals to df social double square brackets and put this one inside that. Okay, and you shuffle it, whichever one you want it first, you can keep this one in the starting. Now this is called as shuffling. Now what you are doing is renaming the columns. Okay, there is df columns, age, estimated salary and purchased. One, sorry. Okay, this is what we got it. Clear, guys? Now what you have to do it, which one is that you want to predict it over here? Which one you want to predict it? Purchased. So the are there. Out of them, purchased is the one we are going to predict it. That is dependent. So always the dependent column will be in Y, in the Y, and rest of all should be there in X. So let's take the X, capital X. All the independent variables will be in the capital X and dependent will be in the Y. Now what are should come into the X? Gender female, gender male, age, estimated salary. This should get into X and this should get into Y. So what I will do it is f1.drop, and you want to drop it. Purchased. Access is equals to 1. So I'm dropping off purchase. When I drop the purchase, what is left out? Gender, male, female, age, estimated. That will come into the X. Okay. So X dot shape is equals to this. Now if you want to see the X dot head, you see this, I got that. This is having all the independent data. Now what is the dependent data? What is the dependent? I is equals to df social upper purchased. One thing you have to make sure that this should be always in the 2-dimension data frame, and this you can keep it in 1 dimension or 2 dimension. So we have done it. Next step is what? Splitting. Splitting. How to split it, guys? निकलो बाहर, come out of that. कुछ और भी सीखे थे हम कल, कुछ और कर रहे थे कल. क्रॉस वैलिडेशन. Use the cross validation. No need of splitting it from here on. Use the cross validation and go forward. So from sklearn, forget about that method. Don't do that. Always try to implement the cross validation. And once we get into the hyperparameter tuning, you should stick to the hyperparameter tuning. Okay? Just forget about this. Dot model selection input k fold. Input k fold. And cross al score. Yeah. Now next step. Object of k fold. Kf is equal to how many folds you want it? 10. With 5 or 10, any folds you can do it. Like I will go with 10. 10 splits is equals to 10. Then next what? Create an object of logistic regression. So how to get the object of logistic regression? From sklearn dot linear underscore model import logistic regression. Okay. Now create an object of LREG is equals to logistic regression. Okay. Now there are some parameters are there inside this. We are going to see it in the future when we are doing with the deep learning. So now LREG. Now what? Yeah. Huh? Object बनानी है. How to implement the cross validation? Cross val score. Cross val score. This will take LREG. Estimator is LREG x comma y. Here. That's it. Now this will give us the. What it will give us? 10 different accuracy scores. So I will say that LREG score. How many scores you will get it, guys? 10 scores. Okay. Now what is that? How to find out which one is the best? LREG score dot mean. Got it 69%. Okay. हाँ 66 आ रहा है कहीं गलती कर ली है क्या हुआ ड्रॉप n कर दिएगा तो चलेगा now what is this next solution now you got only this data and your accuracy score is less and at any cost you want this data to be worked out then I told you some mechanisms. One is scaling mechanism. Apply the scaling. So let's do with the scaling, guys. From sklearn dot reprocessing, right? Reprocessing के अंदर ही है ना वो. Import standard scalar. Okay. Then create an object of the standard scalar. Sir, Mike. Into chindi accuracy cross validation you applied cross validation okay with the 10 splits पर कुछ प्रॉब्लम हो रहा है ठीक है कोई दिक्कत नहीं so I created an object of SS that is standard scalar समझ में आ रहा है आ जाएगा so you will be doing the standard scalar okay now in this standard scalar we are going to fit the data what is the data we are going to fit x x we are going to do it not x and y we are going to fit x now we don't have x train y train we have the x and this I will give it as x underscore ss so you check it out your x underscore ss is this sorry I have to transform it so I just now I have to transform it ss dot transform x now I'm done this is the one you got it. Now you apply this one into your model. This, let's try it out if I can do this. Cross LREG 1 is equals to logistic regression and then cross val score here lreg run comma x underscore ss by and cf tv is equals to kf. Okay? And here you will get the score. See that it works. Score dot mean 82%. आ गया 82%. Got it, guys? Yeah. बढ़िया है, ले लो. Some mistake, I think. So more my data must be a bit changed, or I didn't drop the one. I have to drop first. I didn't drop it. Maybe I should have dropped it. I didn't drop it. That is showing effect over there. Okay, guys, clear? आ गया. How much? 89. क्या हुआ? 5 splits लिए. कितना है? स्कोर तो बताइए. After doing this scaling नहीं करे. 74 आ गया तो बस है. कितना? 82.5. आपने भी ड्रॉप नहीं किया. ठीक है. You try dropping this one. Should be dropped off. तो मैं सही हूं, आप गलत हो. ठीक है guys. So this is what is the one which we have to do it. Got it? Ilai Raja. You got it? Prem. टेंशन मत लो, ये पूरा आ जाएगा आपको. चिंदा 82.5. Yeah? Guys who are online, how much is the score you got it? सो रहे हैं. कल एक बंदा आया था ऑनलाइन वाला, वो कुछ भी नहीं कर रहा है. आप पूछा. So let's take the next one, guys. Next, there is a one more data set is there. It's called as mining sonar. Sonar. This is the one sonar. You got it, guys? See, this is a very powerful data set. You can directly keep it in your resume for this. Now, first one is import numpy as np, import pandas as pd. Okay. Now then we are going to read the data set. I'm going to put on this one, and here last I'll change the name of this one. I'll give it as only sonar. Sonar.csv. Now try to understand this one, guys. आ गया finished అయిపోయిందా how much 82.5 రౌండ్ ఫిగర్ చేయగట్లా 82.5 okay finished guys yeah let me do that Hassan हाँ नहीं है इसलिए बोल रहा था देखो यहाँ बोल के कहाँ देख रहे आप so guys this set so this one is not having the column labels so whenever you get the data into the pandas so the first row whatever is there in the CSV file will be by default it will take it as column labels but in this data set we are not having any column labels over here if you check it out there is no column labels at all yeah so the first one whatever is there that is being taken as a column label that is the not the right one okay that is not the right way of doing it so I don't want that to be taken as a column label see these are so many columns are there can you see it around 60 columns are there 60 or 65 I don't know the last one is saying that the output the what is this data set is see usually when you go into the ship like when a ship goes into the water so it will send the signals sonar signals and it will return back that signals and it will catch it and looking at the reading it will say that whether it is a mine or a rock now here you can see mine M stands for mine R stands for rocks so here by default what it will do is like it will send the signals and it will get the readings in number of readings it will take it 60 readings it will take it now each and every reading they can't keep it a name for that column it is not like what is your name father name not like that it's each and every time they will say they send the signal and get it so there is no particular name for that no particular name for that so what we are going to do it is we want the first column should not be considered as a column label so how to do that so you have to say that while reading only there is an attribute called as header header is equals to none when you give it none so it will not consider the first column as the header now you see this now you will get all the first column everything you will be getting it how many readings I am having 208 the columns are 61 now out of this 60 is independent and 1 is dependent what is the last one is dependent remember this last one is dependent okay? now you see the 60 the 61 is there this one is a dependent okay clear guys now the question is there are no nulls sure that there are no nulls df what's the name df1 or df sonar I will take it how to do the slice how to get the x guys is in a is a function which try to find out the empty values dot sum empty I will get it like how many is there any empty is there nothing is there okay now guys how to get the x value drop okay or other way slicing कैसा करते हैं column slicing minus row కాదు column కదా కావాల్సి. So df sonar dot loc of colon and you are saying from starting to where you wanted. What do you mean by second last? 60 है ना, 60 दिए तो 59 डूब जाएगा. So we will give it as 60 or 61, index 60. So we will give it 60. And let me do this. Did I get it? 60. 60 I got it. I have to give it to, sorry, it is column labels, right? So 59. I'll use it as 59. So I'll be getting it, except in the last one, I got all the data over here. Can you see it? 59. This is my X. Here, this is my X, guys. What is a Y? Y is equals to df sonar. But can I give it like this? 60. Got it, all the 60. Okay. Now this is now out of this. If you take it, we are having around 60 columns are there. 61 columns are there. Out of that, 60 are, you know, independent and one is dependent. Okay. Now 60 I took it in the X and one I took it in the Y. Right, guys? One I took it in the Y. Now this one, we need to encode it. Yes, we need to encode it. So we are going to encode it, guys. cd dot get dummies and give it by, okay, comma drop first is equals to 2. And let me see this. I got it R. That is rock. I got all the rocks over here. This I will give it as df. You can put it in the Y only direct. Now Y is this one, guys. Here, my Y is this one. Okay. See, first I got the data set over here. Now this data set is not having the labels. So what I did it is I did the header is equals to none. When I did header is equals to none, so it gave a default headers like 0, 1, 2, 3. Why I did it this one? I have to do the header is equals to none because the first row will be taken as a column label. So I don't want that to be taken. So I want the first from the first row should be considered as a data. So I gave it header is equals to none. So I got it 0, 1, 2, 3, 4, 5, 6, something like this. Okay. Out of this, what I did it is I split it from 0 to 59 as X and 60th as Y. 60th is in categorical column. So I have to encode it. When you want to encode it, you will use the get dummies and you will encode it. And you know why we have to use the drop first, right? To avoid the what is the problem we will facing over here? Dummy variable trap. To avoid the dummy variable trap, we are going to do this. Now, what is the next step, guys? Splitting. Okay, we want to split it. How to split it? sklearn dot reprocessing import, sorry, model selection import k-fold and cross validation. Okay. Here now k-fold, how much we are taking? 10 split to 10 you will get. And then I will give the name as KF. And what is that algorithm we are going to take it, guys? Logistic regression from linear underscore model input logistic regression. Okay, now logistic regression log reg. We have done this. Now use the cross val score inside this. First is we are going to give the algorithm, then x comma I comma CV is equals to KF. This n jobs is also there. That is to use the number of codes. You can do it later on. Score is equals to score. So let me do this. It's showing me a warning. You got the same warning? I ignore it. Now I'll go score dot mean 52%. Horrible. Without converting it into this. तो वो सही नहीं है ना वो. You can't trust that. Now let's apply this. You tried with this one. Same आ रहा ना 0.5. So वो it's not reliable if you are going with train test that is a holdout. It is not the reliable one. You should never go with that. So now let's apply the feature scaling, guys. Can we apply feature scaling? Can we try it? We should get the accuracy much better. I don't know why we are not getting. Let me see that. From you can ignore this one's warnings by inputting warnings, guys. There is something called as warning. Warnings. You can use it. B is equals to warnings or filter warnings, right? Ignore. This one. Now let me do this one. It's the same. So let's do with the feature scaling, guys. Standard scalar. Let me do it something over here. Max iteration. Is the same we are getting it. Okay. I will give this one as SS is equals to now SS dot fit of X. SS dot fit of X. Transform, sorry. Transform X. And this I will give it as X underscore SS. Now I'll forward it again to a cross validation. Log reg 1 is equals to logistic regression, and cross val score log reg 1 comma x underscore ss comma y cb is equals to f. Let's see the score. Log 1 score. The same. You're not getting it. Maybe this is not the right thing because this data is not linearly separable one. Let's try it out with the same with the other algorithms like SVM and decision tree. How much you got it? 56 here. Which I think that we have to change the algorithm. So once we know multiple algorithms, right, we can pass it on all of them with a different algorithms at a stretch. Like if suppose आप decision tree बना दिए, algo list you make it. First you will make it as log reg, decision tree, and random forest, and SVM, all these things, and you pass it on the data from each and every. Which one is better? You are going to get the output. Okay, here guys. Let's see the next one. So let's take this diabetes data set, guys. Want to leave? Yeah. So let's deal with the diabetes data set, guys. Got the accuracy? हो गया? How much? Same. डिसीजन ट्री कम हो गया. देखेंगे आ जाएगा. SVM ट्राई करो. SVC. Import pandas as PD. Cross validation. Again, you re-execute the split. From the split, you re-execute it. From the split, what is the this? What is your independent and dependent? Which one is your independent column and which one is dependent column? Huh? Outcome. And there is one more thing is there. Have you observed it? Now there is, if you check it out here, insulin is having 0 and skin thickness is 0. How can it be zeros? Insulin lo zeros ఉన్నాయి చూడండి. Insulin should not be 0. And here this one should not be 0. And यहाँ पर भी 0 है. Blood pressure is 0. How can, what are those outliers? Algorithm పెట్టి accuracy తీయడం కాదు. Remove them, remove these things, and then you can. How to remove these guys? How to remove them? How to remove the zeros over here? Huh? Linear. అర్థం కాదు. NaNA और टॉप कन्वर्ट NaN एंड टॉप Na. तो क्या होगा? आपके पास कितना डेटा है? कितना है डेटा? 7600 ही है. उसमें से पूरा निकाल दिया तो क्या रहेगा? कुछ भी नहीं रहेगा. मीन डालो वहां पे. Put on the mean, remove the zeros and convert the zeros to NaNs and then fill up with the mean. Got it? Clear? Now let me take this one, guys. Now I want you to know how many columns we are having with zeros. 2 columns. ఎక్కువనే చూడండి. స్కిన్ థిక్నెస్ లో ఉంది, బ్లడ్ ప్రెషర్ లో ఉంది, ఇన్సులిన్ లో ఉన్నాయి. क्या अप्लाई करो ना, फिर पता करो कितना जीरोस है उसमें. इज इक्वल्स टू 0 डालो, उसमें पता चल जाएगा ना. कैसा पता करना बोल तो pd.read_csv see the glucose. I don't know whether zeros are there or not. Try it out. If it is zeros are there, convert to NaN. Blood pressure, you know that there are some, we have seen some Na zeros. Thickness, there are some zeros. Insulin, there are some zeros. And these are the stuff you find out whether there is zeros or not. These 5. How to do this? First, DF. I'll take it as DF1. DF1 columns. So what are the columns you are going to consider? The glucose, blood pressure, thickness, insulin, and BMI. These are the ones we are going to consider it. Okay? Let's do this one. I'll take a list of columns, all list. Okay. Now call list, you got it. Guys, now can you tell me how to remove the zeros from here? करो, सबके लिए करना है. How you? I want you to make a function or a some or other way, you should replace the zeros with NaN, and I want you to put the value mean. हाँ बोलो कैसे करते हैं? हाँ सब एक ही झटके में हो जाना है। हाँ बढ़ा दो, वही तो बोल रहा था। हाँ बोलो। Simple. This is the reason why you learn the Python. They spend so much of time. So first, if you take it at glucose, how to find out whether there is zeros or not? df what? df1 of glucose. Okay. Glucose double equal to 0 कैसे आ जाएगा? पूरा जीरो हो जाएगा क्या यहाँ पे? You are comparing complete this thing with the zeros. क्या होगा? नहीं जीरो ही है ना, लेस देन 1 नहीं, जीरो ही है वहां पर. Dot replace, or you can do it like this also. देखो फिर कैसा है, कैसे चेक करेंगे इसको? डाल दो. क्या आएगा? These are the ones which are glucose. This. How many are there? But I want to replace it with NaN. कैसे करते हैं? इसको डॉट रिप्लेस. आगे पीछे नहीं, पूरा बताओ. ये क्या है? df1 dot glucose, guys, glucose dot replace 0 NaN, 0 with np dot NaN. Okay? np dot NaN. Now let's see that we are going to get it anything. Okay. Now it should be replaced. Now after this, I will see that dot is Na. Sum. 5 of them are there. How many zeros are there? 5 zeros. So 5 of them is replaced. Right? Is this a permanent change? No. So how to replace it? How to make it as a permanent change? It as in case is equals to 2. पर है क्या in case? Call it domain. df1 of glucose. What mean? आ गया? Okay. Is this a permanent change, guys? No, this is not a permanent change. I will just check it out. What is the mean over here? What is the mean? What is NaN dot sum? You can see 0 are there, so it has been replaced. But ये नहीं चाहिए ना मुझे, पूरे सबके चाहिए. हाँ बोलो कैसे करते हैं? वहाँ बोलो कैसे मारते हैं? ये ले लो ना, हाथ क्या मार रहे हो ऐसा? ये करो यहाँ पर. ये भाई साहब का क्या हुआ? Yeah, tell me how to change it. Just take this one, guys. Simply call list कुछ है क्या? Call underscore list for I in or X in call list. What you are going to get it, guys? Different column names. Okay? In this, you keep this one. Inside this, you keep it. Okay? In the place of glucose, keep what? X. And here also, make it as X. इसमें in place है क्या? Is there any in place? Replace में in place नहीं है. In place है. So when we do this, guys, so we should get all them. Yeah, that should be working out for us. Now DF glucose is equals to 0. DF sorry, don't have any zeros, so all of them are removed. Now you apply your logistic regression and you should get the accuracy, guys. That is the way you have to do it. Okay, now you do it. Now you apply the accuracy score. Let's see that. So DF1 have it. Now it is perfect now. Hope that age is not 0. एज में 0 है क्या? No. So I will have df1 dot columns. Will remove the outcome. dfx is equals to df1 drop outcome so now y is equals to df1 of outcome. Let y. Now you got to split it from scalar dot model selection import k-fold and cross validation. So k-fold we are going to keep it as 5 folds as it is. Kf. For my logistic regression from sklearn dot linear model import logistic regression. Create an object of logistic regression. So LG model, I'm going to give it as cross validation. LG model comma x comma y CV is equals to KF. LG. It's a warning. सेम आ रहा है क्या 76? You have to check it out if there is any outliers are there in that. Check it, outliers are there or not in the glucose, in the blood pressure. So how to check the outliers, guys? Mean, yeah, apply the mean function and you can do it. Just how we did it as single spread over here. The same way you have to apply it a function where you can pass it on and it will identify the errors and it will, you know, because it's a very small data set, definitely you have to go with the capping only. There's no option of trimming. So we can't do the trimming over here. Okay. Now, clear? Hope you are clear with this. Now, again, I'm saying it, the accuracy is up and down. This will be happening. There are so many ways you can rectify these things and you can get more and more. And there's a tuning way also you can do it. That's what I was saying it. Now you can change values inside this. You can do the shuffle. Okay, shuffling means each and every time the data set will be shuffled. And there is inside this also there are so many parameters will be there. Penalty is L2. L2 is regularization. L2 is called as what? Ridge. L2 regression is ridge. And here tolerance you can reduce it. And C should not be touched. And these are the different parameters, guys. You can try it out over here, different parameters, and you can see that. Okay, you will be getting it like how to inverse the regularization 0.1 that should not be touched. So how to reverse that one? There are different parameters are there. We'll be seeing this one in the future, like one after that. Okay, these parameters we are going to collect a set of parameters and we are going to pass them. Clear, guys? Okay, let's move on to the next algorithm called as you can apply the map function, no problem. It's up to you how you want to do that. But ultimately see that don't drop that because the data set is very small. Right? They are not, if the zero is there in that, the value will be, if the zero is there, then it is a valid. If the value 0 is there in the diabetes degree functions, if 0 is there, see the readings over there, how it is 0.62, 0.35, 0.67. So it is understandable. Yes. So try it all of them, guys, because you know what we are going to do it ultimately. As we learn 2 or 3 classification algorithms, we will pass the data to the 2 or 3 classification algorithm. Automatically, you are going to build up an auto ML model. That is, you are not worried about the which algorithm to be used. Automatically, you will pass the data and it will go through the different stuff, and I want you to prepare a function which can remove the outliers from each and every column. It has to remove the outliers on its own. You pass on the data, automatically it will remove the outliers. That we have shown you also. So you have to do that. So that this all putting one at AutoML, like all the algorithms at one place, and all the outlier detection at one place, and doing the scaling mechanism, this in turn will form up a framework. This is very important for your model, guys. Okay, so let's start the new one, or we'll start it tomorrow. हाँ वही कर सकते हैं, करके कंप्लीट भी कर सकते हैं, होना बोलते. So guys, let's go with a new algorithm called as KNN. So that is stands for K nearest neighbor. See, there are multiple classification algorithms will be there, multiple of them. But the difference is each and every algorithm will be considered a different mechanism. Based on that, it is going to. Now, KNN is an algorithm which is called as a lazy learner. So why it is called a lazy learner is, see, usually when you take an algorithm over here, any algorithm, KNN. So any algorithm you will do it is, what it will do is like, it will take your independent data, okay, independent data, and it will look at your dependent data, and it will try to get and understand the relationship between them. Okay, it will try to understand the relationship between them. When a new data set is given, suppose a new point is given, new value is given, based on this understanding, when you give it, it will calculate and give us the what will be the value. Okay, this is the actual mechanism of all the algorithms. First, it will take the independent data, then it will take the dependent data, and it will try to understand the relationship between them. How an independent data is giving us the dependent data, or how a dependent data is depends on the independent data. This is what we are going to get. Okay, so this is actually the relationship. It will know it. Once it knows the relationship, when you give a predicting value, when you want to give a predicting value, automatically it will give us the output. On what basis? Whatever it learned it over here. Whatever it learned it over here. But in KNN, it is called as non-parametric, first of all. And it is also called as a lazy learner, because if you give an data over here, that there is some data over here and there is some data over here. So what it will do is like, it will not learn anything from this. It will not at all learn anything until and unless you will tell us like, what is this? Now this is a group A and group B, and there is a group C. Data is there. Group A, group B, group C. Now this group A, group B, group C, first we will give the group A data, group B data, group C data. It will just know it. It will not analyze, it will not do anything. Because, you know, if it learn also, it will not make any difference for it. Why? Means until and unless a predicted value, when we ask the prediction. Suppose here there is a group A data, here group data, group C data is there. Now there is a new data comes up over here, new data point. Now which this data point belongs to which category. Either it belongs to A category, or either it belongs to B category, either it belongs to C category. How to say that? That is by calculating the distance between this data point to this A category, and this data point to B category, and this data point to C category. We are going to calculate the distance. And after calculating the distance, where it is very close to which category, we are going to put it in that category. This is how the actually KNN works. Now suppose, just imagine this is a data is there. Now take it, this is all circles are there with you. Okay. And here all plus are there. And here all stars are there. Now, see this. If I am saying it, I want to find out a data value over here is there. Now, which category it belongs to? Either it belongs to circles or plus or star. How to do that? So, what we are going to do it is, we are going to calculate the distance between the nearest points. We will calculate the distance from here to here. We calculate the distance from here to here. We calculate the distance from here to here. Okay, how many data points we took it? 3 data points. So it may happen 3 data points, or you can take it 5 data points. You can take it 7 data points, or 9, like this. You can do it any. Suppose I take the 5, then I will go with this one, and there is this one is the nearest one. Okay, now these are very far, right? They are very far. Now I will take the next one is this one. Okay, how many we became? Like 5, or let's do it like this. One more star is over here. Just imagine one more star is over here. Now first point is this, then this star, then this star, and this star. So total 5 points we have to get, 5 nearest neighbors. And out of this, 1 is circle, 1 is plus, and 3 are star. So the maximum number of votes are coming from the star. So automatically we are going to put this one in this category. Got it, guys? We are going to push this one in this category. Now just think that if data point is not here, okay, data point is not here, data point is here, which category it is? Circle. If data point is here, which category it is? Plus, right? Clear? Now, on what basis you are saying this? It belongs to star and it belongs to distance. When you are able to calculate the distance, see, you got the data, this one, you got this data, right? This category data and this category data. You got the data now. Readily I gave it. Now you start calculating the distance. You will calculate the distance now. Now I gave the data. You will start calculating the distance. You will calculate the distance from here to here, here to here, here to here, here to here. You will do that. Why? Why you are not doing it? Why you are not doing it? What happens if you calculate? So suppose, just imagine, you got the data. You got this data. This is your training data. Okay. You started collecting the distance, calculating the distance. Now you calculated the distance from this star to this star, this one to this, this one to this, this one to this. All this you did it. Okay. All this. Okay. Like this you did it. From this stars to this one. All these things. From this category to nearest ones you calculate. Now you are predicting. The one which you want to predict came up over here. Will this calculation. Will this be helpful? No, you will not helpful. Where is the data? Data is over here. You have to categorize this data either into this one or into this one. If you learn this distance is waste. So in this case, in the KNN case, when the training data is given, there is no internal calculations or internal mechanism will be not learned from the model. When a model is not learning any internal mechanism, that is called as, it is not looking into internal understanding how the data is being, dependent data and the independent data are connected. When it is not looking at that, that is called as non-parametric. Non-parametric means it is not going to perform any calculations between the training data to understand the relationship. That is what is called as non-parametric. And it is a lazy learner. Why it is a lazy learner means, see, if you have, this is like to start learning the distance from here to here, here to here, sorry. You are having all this distance you calculated, from this category. Will that be any useful for you? No. Until and unless you get your predicted value, this distance calculation is purely waste. Okay. So when you should calculate the distance, only after getting the predicted value, which you want to get the predicted value, then only you start calculating the distance. So in all the other algorithms, what it will do is like, it will understand the internal mechanism, relationship between independent data and the dependent data. And as soon as the predicted value comes, it will calculate it based on the understanding. That is an early learners. That is the best way of doing it. But in this scenario, KNN scenario, here, if the model start learning early, it will not make any use at all. Why? Until and unless we don't know where is the predicted value. After getting the predicted value only, you will start calculating the distance. So that is the reason why until and unless the prediction value comes down, you will not start learning. That is the reason why it is called as lazy learner. Okay, lazy learner means it will not do any calculations until and unless the predicted value comes into the picture. Okay, that's why it is called. And this is one of the easiest algorithms available, guys. Now the question is, how this is calculated, how the distance is calculated, on what basis the distance is calculated. See, first thing is, there are some hyperparameters are there which are called as K. Now K is nothing but number of neighbors. Neighbors, guys. K is nothing but number of neighbors. So if you want to take a data set over here, there is one data point over here, and here there is a one cluster of the data, and here there is another cluster of the data. Now see this, your data is over here. Just imagine, here all stars are there, all stars, and here all triangles are there. And this all circles are there. Just imagine like this, all circles are there. Now what the KNN will do is like, by default, it will start calculating the distance. Now if you take it K is equals to 1, then what happens is it will take the only one closest nearest point from this one. Whatever the prediction value is there, from here, which one is the closest one, only one data point it will consider. So suppose this is the closest distance. Then by looking at this one, it will put into the category of triangles. Okay, triangles it will put it. But is it right means no, we can't say it, because sometimes the A star may be very close to this, Actually, this is an error. This star is an error, outlier, which is out of the actual stars. Now, but this is very close to this. Now, can you put down this one under star? No, that is wrong. To avoid that situation, what we are going to do it is, we are going to take it a minimum of 3 or 5. 3 or 5 as a K. By default, you will be having 5 or 8 or 9, or mostly this will be odd value. K value will be odd. There are two ways we can calculate it, odd, this K value. So if I'm saying 3, then it will take the 3 nearest values. Got it, guys? It will take the nearest 3 values. It will calculate the distance for this one, calculate the distance for this one, calculate the distance, this one, like this. It will calculate the distance and it will find out the 3 nearest values. And out of the 3, how many maximum are pointing out to which data set, that will be going into that category, simply. Okay. Now you may ask me, what if all of them are equal? There's no question of equal. That's the reason why we will take an odd number. So there's no question of equal will be there usually. So if it is still odd, it is there. Then you take the mean of the distance. The distance mean will be taken. Suppose here 2 of them are there, here 2 of them, here 3 of them. Then this comes into this category. Suppose if there are only, like 1 is over here, just take it, 1 is over here. Now this is having 2, this is having 2. Then what you will do, we will take the mean of this distance, both distance, we will take the mean and we will find out which is the nearest distance, and we will be doing. Got it, guys? Now the question is how to find out the distance. So you know the first thing is how it is categorized. Based on, we will take the K value. K value 5 means we are going to take the 5 nearest values, nearest data points, and we will see that how many maximum are pointing out to which category. We will put our predicted value in that category. Simple. We are going to follow this one. Suppose this is actually the geometric intuition of this one. So suppose now this is now K value. How to calculate the K value? There are 2 ways we can calculate that K value. One is take the entire data set, complete data set. Well, how many values are there? Length of data set. Length of data set, and find the square root of that. Find the square root of that. Then this will be coming as the K. And one more important point should be K should be always odd. It should not be even. So suppose if your square root is coming down like 12, is this odd or even? So you are going to subtract 1 from it and make it 11, like this. Okay. Now suppose again, if your data set is like 1 lakh or 10 lakhs, then your square root will be very big. Square root will be really very big. To avoid that case, what you are going to do it is, you are going to split the data into training data and test data, right? You can take it X train or Y train, anything you can take. Now find out the length of Y test or Y train and do the square root. And see that they should be decently, the value should be around 12 to 25, something like that, below 100. If it is above 100, then don't take that one. If you are doing the square root of this length of Y train or X train, square root you have done it. Now you are getting like around 250. Then don't take this. Take the other one. What is that? Y test length of and find the square root. Okay, guys. So these are the ways you will be doing the first way. Second way is hyperparameter tuning. That is, simply take a list of values, like put a list of values over here, like start with 3, 5, 7, 9, 13, or 15, something like this, or 19, something. You do this and pass it on one value at a time to the X. Okay, you will pass one value at a time to the X. When you pass it and see that which one is getting the maximum closest point, then you can go with that. Okay, so this is the way. Now the most important point is this one. The K plays a very vital role over here. K says that number of neighbors around this. Okay guys, now what is the distance? How the distance is calculated? There are multiple ways are there, guys, to calculate the distance. The very popular way is called as Euclidean distance. Euclidean distance. Now, what is the Euclidean distance is? Now, if there is an graph is there like this, guys. You want to find out a data point is over here. Now, this is a two-dimension graph. So the data point will be having two values. One is towards the X and other one is towards the Y. This value we can take it as X1 and Y1. Suppose take it X1 and Y1. There is another point is there over here. This value will also have the two coordinates. One is X2 and Y2. Okay. Now the distance between these 2 points is calculated by like this. So how this is nothing but a Pythagoras theorem. If you know this, so if there is a distance between any 2 points I want to calculate, suppose this is A and this is B and this is C, just imagine. Now you can say that BC square is equals to AB square plus AC square, right? Now this BC can be done as square root of AB square plus AC square. Got it, guys? This is the formula. We use it as a Pythagoras theorem over here. In this case, okay, if this one is the X1, right? This one is what? X2. Now this one is what? Y1. This one is what? Y2. Now what is the formula will be? This one is equals to this plus this square root, right? That is X2 whole square plus Y2 minus Y1 whole square root. This is called as, you know, this distance. Now this is the Euclidean distance formula. So that is X2 minus X1, X2 minus X1 into Y2 minus Y1 to whole square root. Then you will get that. This is the Euclidean distance formula. Okay, clear? Now, hope you got this point. X2 minus X1. This completely is called as X2. I want to get this point. So I have to subtract this one, right? This one is X1. X2 minus X1 is equals to this. Yes or no? X2 is complete this one, guys. And I'm subtracting this one. So what is left out? This one is left out. Now in the same way here, Y2 is complete this one. I'm removing this one. So you will get this one. Clear? Now when you add it and square it, that is called as Euclidean distance. Now there is one more called as Manhattan distance. The two distances are there. One is the Euclidean distance. Manhattan distance. Now suppose, just take it. If you want to go to a place, you are standing over here and you want to reach a place over here. Now the route is, you don't have now all the buildings are over here. Just take it, all the buildings are in the middle. So the route which you take it is from here to here to reach this point. right? This way of going is called as Manhattan distance. Now, if you are directly reaching from here to here, this is called as Euclidean distance. That is the difference between a Manhattan distance and the Euclidean distance. Got it, guys? So in this case, if you have a graph over here, if this is a graph is there, now you want to reach out to the point from here to here, then what you're going to do, you're going to use the Pythagoras theorem and you will get this distance. This is called as Euclidean distance. But when it comes to the Manhattan distance, you're going to go from here to here, and this is called as Manhattan distance. So usually we will not use the Manhattan distance. We usually go with the Euclidean distance. Now let me quickly see that if I have a presentation over here. Now, again, this is one of the basic algorithms no one will ask you. That's for sure. And this is what you call it as K nearest neighbor algorithm. So it is K nearest neighbor algorithm is a simple supervised machine learning algorithm that can be used to solve the both classification and regression is also there, which predicts a target variable using a one or multiple dependent variables. So we are going to calculate the distance between a target variable to the multiple independent variables. Based on that, you will calculate it. Okay. Now this is the one. You can see this. K is the number of nearest neighbors. K is the number of nearest neighbors. Number of neighbors is the four deciding factors. These are the ones who will be deciding actually where they will belong. Now, if this is my point, question, the new sample over here, the question mark. So I'm taking K is equals to 1. When I take the K is equals to 1, then it will take the nearest K and we will put it in that category. But there is a lot of problem over here. If this star comes over here, the other side, maybe it not belongs to a star at all. It may be a triangle. So when the star is over here, you're going to consider only the star and you will do it. That means to say is, if there is outliers are there, your KNN will be very wrong when you take K is equals to 1. To avoid this, we increase the value of the K from 3, 5 or 7, 9 like this, as I told you. Now here you see. If there is K is equals to 6 over here, 6 or 7, it should not be 6. So we are going to take it like this. Nearest distance. And here in this case, we are going to consider the only 3 of them in this case. The K is equals to 3. You see it? K is equals to 3. We have considered 3. Out of them 2 are triangles. So I will put it in the triangle case. So how to find out this nearest one is calculating using the Euclidean distance. So it is called as instance-based learning. So it will learn it instantly. It is not going to pre-plan. It will not learn. It is a lazy learner. As I told you, there's no point in learning from the training data and the testing data before ahead. It purely depends on the whatever the sample you want to predict it. Based on that position, it will start learning from the nearest distance. It will calculate it. So that is the reason why it is called as a lazy learner. And non-parametric, as I said it, makes no assumptions about the functions, forms of the being. It will not get any internal mechanism, in other words. Okay. Now this is a way it will be. If you take it K is equals to 3, then you are going to take the 3 nearest neighbors. Nearest neighbors. How you will calculate the nearest neighbors? By calculating the distance. And how you will calculate the distance? By Euclidean distance, guys. Okay, Euclidean distance. This is like आउटलायर रहेगा ना, आउटलायर रहे तो प्रॉब्लम नहीं, आउटलायर नहीं है तो कुछ भी नहीं प्रॉब्लम नहीं। वही पर रहेगा नजदीक, whatever the nearby is there, you are going to take it. See, there are some consequences will be definite. Again, this is good for small data. If your small data is there, it's good. अगर सोचो तो अगर you are having like 10 lakh or 20 lakh or 1 crore data points, then क्या होगा? It has to calculate the distance for each and every. That is a big problem. So this is not a right one. That's why they say it like this is a basic algorithm, very much basic algorithm in the classification, and it is used for only a small data sets when there is a very small data sets is there. And again, preferably no one will use this one in the high end stuff. Okay? So if there is k is equals to 3, then this is the way it will consider. How many are squares? 2. How many are triangle? 1. So maximum votes are for the square. If you put it in the square, if you take it 3, so if you take it this case 3 and here 7, see the difference. If I am taking 3, I'm classifying it as a square, but if I take it 7, then it is going into the triangle. Got it? The more you take it, the better is the prediction you are going to get it. Okay, the more you have to take it. Here, way you have to choose it. The square root of n, where n is a total number of data points. Again, guys, if the data is small, then you can consider the complete data points and you can do the square root. The data is very huge. Then you have to take it either X train or Y train or X test or Y test. And then you have to do the square root. Okay. Now, and one more important, most important thing is it should be always odd value only. K value cannot be even at all. Okay. Now, this is the way how you calculate it. This is the first point, A comma B, and this is X comma Y. So you will put on as X minus A whole square plus Y minus B whole square. Okay. Now, this can be also written as summation of X minus X, X minus X or X minus Y, you can put it whole square. Then it will Xi by Yi whole square, you can put it on. Now this is the Pythagoras theorem, guys, through which we resolve it. That's it. Finished. Okay. Yes. Question. Okay. We'll do the implementation. You can directly implement these things. It's very easy. It will be under the neighbors. sklearn.neighbors and import neighbor classifier or neighbor regressor will be there. The same data sets we will use it, guys, for implementing this one. Okay, let's meet tomorrow continuing with this one.